I'm going to start telling you just a little bit about our panel. You've met most of them in the video, and I'm going to make these bios really short so you can hear more from them rather than about them, but so that you know who you're talking to. Adam Hergis leads the Mosaic Company's North American Nutrient Stewardship, Strategic Partnerships, Sustainable Agriculture Initiatives, which deal with climate and water quality and external relations. He's got a BS in Applied Plant Sciences, Plant Improvement, and MS in Agronomy from the University of Minnesota, and former positions with South Dakota Soybean Association, the South Dakota Soybean Research and Promotion Council, and the University of Minnesota, and the Minnesota Department of Agriculture. Also going to introduce Dr. Laura Johnson, who you met in the video. She's the director of the National Center for Water Quality Research at Heidelberg University in Tiffin, Ohio. At the National Center, long-term monitoring of streams and rivers is used to examine the influence of human activities on water quality and help decide actions that lead to healthier ecosystems. Laura is best known for research examining the linkages between agricultural runoff and harmful algal blooms in Lake Erie. And when we talk about better known, we mean like being quoted in National Geographic. She is truly a global expert. Greg Kniebuehler, a CCA that you met in the video. He's from Harlan, Indiana, northeast of Fort Wayne. He's been operating G&K Concepts, Inc., an independent crop consultant business since 2003 with a team of agronomists. In addition to soil fertility management, variable rate prescriptions, crop scouting, and research plots, their focus has shifted to data management for farmers, including grower network research, sustainability projects, and overall analysis of information for better decision making, both financially and environmentally. So he's the fifth R guy with the data. And Les Seiler, our farmer, the no-till license plate probably says it all. He is a longtime no-tiller with his brother Jerry in Fayette, in Northwest Ohio. They farm 1,685 acres growing alfalfa, barley, corn, soybeans, and wheat. Soil health and water quality are especially important to them. And they have 35 years of continuous no-till and 12 years of cover crop experience. So with that, we're going to start just talking, answering some questions. And the first question is actually not about phosphorus, but it's an interesting question, and that is about the Woodchip Bioreactors. The question here from Carl Bruce is, wouldn't they eventually release the nitrate that was trapped as the chips decompose? Is anybody big on bioreactors and can explain kind of what happens to those wood chips towards the end of that cycle? Laura's nodding. Do you want to take it?
Sure, yeah. I'm not an expert on woodchip bioreactors themselves, but what woodchip bioreactors are trying to do is enhance a type of microbial process called denitrification. And what that does is it takes nitrate and it turns it into a nitrogen gas, usually dinitrogen gas, which is like 80% of our atmosphere. It's completely inert. So as these woodchip bioreactors age, they're not actually trapping and holding on to nitrogen. They're actually turning it into a gas that would be permanently removed from the system. What makes them run out over time is that that's actually a process. It's like us respiring. These microbes need to grow and eat carbon. And so as the wood chips decompose and go away, basically they just run out of food to eat. Hopefully that makes sense.
So then you're going to clean out that decomposed wood chip material and then replace it with fresh wood chips as a new substrate for the microbes?
Exactly. Yep. That would be the plan. I know there's a lot of research trying to figure out like what the ideal type of wood chip is. I know that there's been some difficulties in finding those ideal types of wood because you don't want it to be too complicated to break down. Otherwise, it might be too hard for the microbes to have that carbon to be able to do the process, but and that's where it gets beyond my expertise, certainly.
Got it. Anybody else? Any other thoughts on wood chip bioreactors? I mean, the good news is they're harder to steal than catalytic converters, so that's good. But basically, it seems like it almost functions similarly. We have another interesting question. What impact could gated smart tiles have on N and P losses via tile drains? And Laura, I know you mentioned the idea of preferential flow. Have you looked at drainage water management systems or gates at the end of tiles and how they may affect P?
I haven't personally, but I collaborate fairly closely with Kevin King, who runs a bunch of edge of field monitoring locations, and his data indicates that the drainage water management doesn't do much for the concentrations of phosphorus necessarily that would be leaving those tile drains for a variety of complicated reasons, but that because it holds water on the field, it actually reduces the total amount that would run off. So you don't see quite as much water leaving fields. The complicated thing about drainage water management is some of the times in which we need to have less water getting to Lake Erie is the time when you want less water on your field. And so that's when you would probably have them free draining. And so it's one of those things to sort of keep in mind. I think automated systems that can be a little bit more fine-tuned probably have more potential for success.
And I promise, Laura, I'm not going to keep putting you on the spot, but since we're on these gated tiles, is there a temporal element is there an advantage to trying to delay the introduction of dissolved reactive phosphorus or any form of phosphorus into the downstream environment? Is there a reason to hang on to that and try to attenuate the flow?
Well, certainly, yeah. The bloom forecast for Lake Erie, so the period of time where it seems like the loading has the biggest influence on how severe a harmful algal bloom would be is usually that spring to early summertime period, starting as early as March but going all the way to the end of July. There's some evidence that if we get a lot of loading, say in June or July, that has a bit more impact than what's happening all the way back in March, just because it's closer to when a bloom can form. But that's really specific to Lake Erie, and that varies, across different aquatic environments that have blooms forming. Sometimes it doesn't really matter. So, if you could pick a time period for phosphorus runoff, you could say, it could be fall or early winter would be beneficial. It would be better than later. But that's why I was saying that usually, if you wanted to prevent runoff in April and May, that's pretty much the worst timing to have really wet fields. At least that's my impression, at least.
That is great. Thank you.
Yeah.
Greg, I'm going to ask you what you're seeing throughout your calling area, the area that you're dealing with. Are you seeing drainage water management being used successfully? Either, we'll open it up to nitrogen too, since it's a 4-hour kind of day. But are you seeing these kinds of tools being used, whether it's bioreactors or drainage water management structures, in a productive way?
So your first question on drainage water management, I'm actually looking out the front window of my office watching tile being installed as we speak. And one thing that we would argue for our client's sake is there's about 2 things you have to manage first before anything else. And that is your soil types and your water. And water management is directly related to tile. And in terms of phosphorus, and we've done several projects with our Amplify network of consultants and just with local clients on edge of field monitoring just to see what kind of phosphorus levels we're seeing in water and water runoff. And I can say what we found is a lot of phosphorus, even if you have a high testing field of phosphorus, if you have good drainage in the field, what we found is it actually retains that phosphorus in the field much better than a field that does not have good drainage. So I can make a pretty good argument for tile and its need for tile. And what it tends to do is tile introduces oxygen into the soil, which also builds structure and soil beds, and you improve your soil structure. And with that, we actually see retention of phosphorus, which is a very positive thing. And so we don't see high levels. Now, compaction and poorly drained soils, I think, moved to the top of the list in terms of contribution to phosphorus and dissolved reactable phosphorus. And so we're actually quite supportive of tile in that regard. As far as woodchip bioreactors, I honestly can't think of one that's near us or somebody that's using one. So I can't really speak to that. We have no experience with that. We do have digesters that are in use, and we have some pretty decent experience around digesters, particularly in the manure world. And we found that through digesters and multiple stage lagoons that we're actually holding phosphorus back. and the final product leaving isn't near as high in phosphorus as before it ever started. So we see some pretty good positive results with that.
That's great. So there's that whole aspect of solids management in manure that, in fact, we have some of that on our website as well, and there's some fascinating science behind that. Les, I'm going to ask you, from your perspective, you've got that two-stage ditch, and of course you've got all kinds of other fields as well. Are you using drainage water management in any way?
Not really. We've got some boxes on some farms that we rent. I'm in an area here, it's Northwest Ohio, Fulton County. There's 60 different identified soil types, and I think we farm over 30 of them. And a lot of the problem that we see is there's a water sand down there, maybe a tile depth, 30 inches or so. And we've had to repair a lot of drainage systems because the heavy events have overwhelmed the tile, and a tile will just sink. An old clay tile will just drop down, and you dig it up and you find it's a gray water sand, completely saturated. And we're blessed to have a good water table that we do. I mean, it's incredible. There's a lot of artesian wells around this area, and I don't know if it has something to do with that. Our aquifer is really a blessing that we deal with, but I just think that's some of the problems. And when you got a fixed tile that have sagged down, you don't really want to keep them full. We want to keep them running. That's
Sure.
What we see.
That makes sense. So going out, again, that two-stage ditch is such a unique structure, and I kind of want to look at that. So going out to that, you've got your drainage tile basically exiting straight out onto the bench, the vegetated bench of that two-stage ditch, and you're letting the vegetation kind of capture sediment and dissolve reactive phosphorus and that kind of thing when those drains are running.
Yeah, that's the purpose of dumping tiles onto the bench, is to try and work with different vegetation. We're planting different things on there to see if different plants will absorb more phosphorus. There's some research being done on it right now, and we planted a bunch of different things last year. So I don't know what that's going to yield, but I mean, that's what we're working towards. And I guess another comment I want to make about tile is soil health. When you improve your aggregate stability and you can take more water in on the land, drainage tile is extremely important to us. We have to have the tile to pull that water level down. But when you get a healthier soil, you don't have a 2-inch crack on the surface. We barely have cracks as things dry out. And I don't think we have the flow as far as the preferential stuff that you see on systems that are heavily tilled yet. I mean, we've noticed a lot of, as our systems are more mature, I think there's still a good fit in letting the soil filter that water, and versus some of the stuff that's heavily tilled and compacted and it splits open 2 inches wide in a dry summer period. It absolutely runs right to the tile. And I think drainage tile for us is just a must, because we have more capacity to hold that water when we get the aggregate stability and improve our soils through soil health practices.
That's a great point. And you've got an interesting scenario on your farm, because I mean, in the video we just saw and in some of that bonus video content I was mentioning on our website, you're standing next to a water quality testing sort of mobile laboratory. Can you tell us a little bit about what's being studied in terms of the outflow off your place?
Yes, that's part of Ohio State University's equipment out there, and they were working some with Kevin King, and that farm had a very high phosphorus number. That is what drew the attention to that, and we do not know why. It doesn't seem to have a legacy or a history of manure or anything, but for whatever reason, there's an area, a soil type on there, a zone that is high in phosphorus. So they asked us about doing some monitoring on it. And I know that early on they was doing grab samples, and they had big ideas of putting a charcoal filter or a big system in there to deal with it. But when they did their grab sampling, they decided that really wasn't necessary, and they started monitoring now. And I guess I'm kind of glad to be a part of that, because it's a more mature system, and maybe that's what we needed to do, is look at some more of these systems that have been long-term no-till and in more cover crops on them to try and tie that stuff up. I mean, it's high for some reason. We don't know why, but I think we have to grow it out with crops.
Yeah, it's interesting to think of soils as maturing even within our own lifetimes. We talked about that in our carbon program 2 weeks ago. That idea that there's a saturation point for sequestered carbon, and we're learning more about what that means and how those dynamics shift. I'm gonna ask this one here. There's a great question here from an Adam Siebert, and I'm gonna ask Adam about this. Our own Adam. He's asking, has CTIC or other organizations done any research to compare in-furrow phosphorus solubilizing microorganisms and phosphate enzymes' ability to offset the 1034O starter fertilizer needs at planting, or phosphorus overall from MAP or DAP? So basically, as I'm understanding the question, are some of these tools, like we heard earlier in this morning's presentation, largely about nitrogen, are some of these tools perhaps available for phosphorus or coming on in any promising kind of way?
Yeah, that's a really interesting question. I mean, there's definitely some new product development occurring, and I think fertilizer, in the most part, from the phosphate side, hasn't been very innovative, at least within maybe 15 years ago, with some of the newer products and micronutrients being attached to modified MAP or DAP product. But I think as we see biostimulants coming up, we see biologicals, I think you're going to start seeing a lot more innovation from the phosphate fertilizer side of things than just the nitrogen side, with some of the really good technology that Alan talked about. That's available for most growers in the U.S.
Great. Now, from that perspective, you mentioned micronutrients too. Are there micronutrients that you're seeing, or relationships with other nutrients, even with the big three, that you're seeing either enhance the uptake of phosphorus or of keeping it in place? Is there anything structural going on or chemical going on in the soil, or biological for that matter, that seems to help with phosphorus management through the management of other nutrients?
Yeah, we definitely see that occurring. Our approach to all this is balanced crop nutrition, and you think about the Lieberg's law of minimum. If you are over applying one nutrient to a plant, it's going to, decrease the ability of that plant to take up the other nutrients that might be available in the soil. And so taking that balanced approach to making sure that, you're supplying even the macronutrients in certain larger quantities, but also the micronutrients as well. Because at the end of the day, the thing that you want to try to control is what you can actually put out there from a crop input standpoint. And if you're lacking in sulfur, Hans kind of touched on that, with having sulfur being part of the Clean Air Act, and now we have less being deposited from the atmosphere. Sulfur is becoming more important for growers, making sure that that's not the nutrient that's causing the plant's ability to optimize yield. So we're seeing that happen out there, and so some of these micronutrients are becoming more and more valuable for our approaches and nutrient management prescriptions.
That makes a lot of sense. So,
Steve, I'll make a couple comments on that.
thank you.
There's been some good buzzwords thrown out here, and Les mentioned one in particular, aggregate stability, and he also mentioned that we can't farm without tile, which we can't. And it's often been a finger pointed at tile as a direct channel to the ditch or to the river. However, I can tell you what we found, and in that short video I mentioned it, and it's the truth, but you can't make any decisions without data, or you shouldn't. And a lot of decisions are made without data, but the bottom line is you got to have proper data to make decisions from. But I can attest to the fact that if you manage your aggregate stability, a lot of times with tile and calcium for that matter, which Adam mentioned, it's about overall soil balance. There is a balance that is required. And what we've noticed is if you basically do a good job by managing your water, managing your aggregate stability through good calcium and mag management, you will retain phosphorus in the field. And we see those fields through years and years of data that we collect, that we will see phosphorus levels actually remain pretty stable and not move on us if you pay attention to those factors that, quite frankly, are in your level of control. And it means that you don't have to just simply go out and apply phosphorus just for the sake of applying phosphorus. And if you manage the system correctly, and which, by the way, goes to the overall soil health or the health of your soil, will retain and maintain phosphorus values over time, and we don't see them moving. If you see phosphorus levels moving through soils information, for example, a lot of times that's a culprit that might be leaving the field through runoff or sedimentation or things like that. But when we see numbers year after year after year, when we test that are remaining pretty stable, that tells me we're doing a good job of keeping phosphorus in the field. And by the way, you can have high phosphorus fields, like Les mentioned. You can have a high phosphorus field that stays high, that's managed appropriately, and the health of that soil is appropriate. And by the way, it's not contaminating the water or contaminating the local water source or ditch. And so it really just comes down to being a good steward and being a good manager of what you're handling. Whether it's applying manure or applying commercial phosphorus or crop removal rates, it's just simply doing a good job, which needs to be backed up with good data so you can confirm what you're doing or what you're not doing, and or make decisions on what you need to change.
Thanks, Greg. That's an awesome point. And I think it leads to an interesting question for Les, and that is, what were the criteria that you used, you and Jerry used, when it came to deciding to not apply phosphorus? Here's something that people always do. It's kind of a tradition, and it's kind of a practice that everybody assumes they have to do, and yet you all have not been applying phosphorus for the past 6 years on your corn. So what did that decision process look like, and what kind of data were you using to both take the leap and ascertain whether what you were doing was the right thing for your operation?
We started using soil testing every other year with, the same network Greg's with, nesters in our area, but the soil zone testing method, and we did it in 2003. And we'd repeat it every year after that, or every other year. Those farms' acres all got sampled that way. So pretty soon you build this database and you start looking at that. And that was, to me, a no-brainer, because it gave me the confidence that I don't need phosphorus on some of these farms. And I mean, if I see that we're mining it or pulling it down on some of the lower ones, we'll deal with it. But I think overall soil health, there's a lot of stuff, phosphorus out there that you can access when you get your soils in in nice shape. And pH is another big factor too, getting that where it needs to be. There's just a lot of good things that watching these every other year soil tests give us a handle on. And it's just a small snapshot in time, but still, when you've got that many years of information, access to that, that's gave me the confidence to say enough's enough.
So now, since you've been, not applying phosphorus to corn, what have your phosphorus levels looked like over the past 6-7 years? And this kind of speaks to a question that Aaron Appleby is asking, which is if P levels are staying constant and P is not being added into the field, how do you account for the phosphorus that's being harvested in biomass? So tell me a little bit about what your phosphorus levels have been looking like and kind of where it's coming from.
Oh, tri-state recommendations have just been updated, and we've got some as low as in the probably high teens, 20s. We're not livestock people, and that was another reason that we wanted to get into the cover crop thing, to start looking at cover crops that might give us the ability to help that, tie it up. We don't bale our straw after wheat or barley. We try to return all that stuff out there. And I mean, is this the biggest unknown in agriculture to me right now is biological. It's out there, it's happening, and everything is connected. It's whether it's beneficial insects or bad ones. I mean, everything out there is connected. And trying to balance that out and understand parts of it is incredibly overwhelming at times. But I really feel that letting Mother Nature do what Mother Nature does is probably not the worst thing, and maybe we better not try and screw it up.
And well, it's an interesting point that you mentioned too, that you're leaving most of the biomass there. You're taking biomass off as grain, but you're leaving almost all the other material back on the field, right? So phosphorus, in that sense, is not being depleted to the extent that it might be if you were taking straw, for instance, or that kind of thing. Greg, are you seeing, have you been kind of tracking phosphorus? Have you looked at sort of the removal and whether the full amount that's being removed is being subtracted from the soil P levels, and if so, are they being replenished from some magic source, or what are you seeing in your data?
Well, that's a good question, Steve. I mean, obviously we have and collect a lot of data, and I'll tell you some basic observations that we've come across is against conventional wisdom, or what we've been led to believe, we actually don't need as high or as much phosphorus to support the crop as what we were led to believe or taught several years ago. And I think part of that goes back to, I think there's recognition out there about recalibrating removal tables and calculations, because we're clearly raising and supporting good crops and good yields on lower numbers than what we were originally taught. And we can confirm that through lots of yield data, lots of soils data, lots of plot work that we've done, particularly in our Nutrient Start program through the Amplify network. I mean, we've got nationwide data that kind of backs that up. So I have a lot of confidence that we can get by on much less phosphorus. Going back to Les's comments, the other thing that we can confirm is just having a healthy soil goes a long ways towards the lack of phosphorus that's actually needed, because a healthier soil will support and sustain a better crop. And there is a lot of buzz out there about biologicals, and I think there's a lot that we've learned, and I think there's a lot to be learned. But I can tell you this, a healthy soil is one that has good aggregate soil PEDs, good oxygen in the soil, good calcium levels. Those types of soils support good biology, good bacteria and good overall healthy soil. I mean, that's a buzzword that's thrown around in industry pretty loosely, but it goes back to just doing a good job of managing your soils. If you do a good job of managing your soils, the overall health of your soil goes up. Your weed knock numbers, your bacterial numbers, your mycorrhizae numbers, they all go up by just simply doing a good job. And a lot of that comes down to water management and introducing oxygen to the soil. And because of that, that plant has grown in a healthier environment, and we found that you can actually get away with less or lower phosphorus.
That is tremendous. So I'm going to ask Laura to kind of take us home. We started with you, and we really put you through the ringer there at the beginning. And so, yeah, I noticed you had your hand up, and I wanted to just see if you could tell us a little bit, first of all, or last of all, about what you've got as resources at the National Center for Water Quality Research, and what else you kind of see that's important for farmers, crop consultants to keep in mind as far as water quality goes.
Sure, yeah. Well, I guess, my hand was up because I wanted to essentially support some of these conversations about, reducing the applications and to only when needed, and pushing those soil test levels down, because I think that, though it's not always super clear that soil test level is not perfectly related to the dissolved phosphorus that comes off, there is clearly at the upper end those linkages. But more importantly, recently in 2019, when folks couldn't get out and actually farm that much because the ground was so wet, we saw a 30% reduction in dissolved phosphorus, which we would attribute to not these amount of phosphorus that's existing already in soils, because that wouldn't change so much from one year to the next, but rather the actual application of that phosphorus. And so, just that one simple act, no matter how much phosphorus you have, of just not applying, or applying at least in the right place and getting off the surface, those things could potentially have a fairly substantial influence that could have an effect on the lake. So, those are the types of resources that we would have. We monitor rivers and streams. We're not up there right at the edge of field. And so we try to work very closely with the folks that are working with like us, looking at what's happening at the edge of field to pair what we're observing with what's actually happening up on the field. But we're not biased towards agriculture. We just happen to have a lot of agricultural watersheds. We also have sites that are measuring non-point source runoff that is mostly residential, or we have areas that are dominated by wastewater treatment plant inputs and those sorts of things. They all have different attributes to them. So you hear me talk a lot about agriculture because we need that to understand Western Lake Erie Basin and Lake Erie. But if there are any other interests or questions about what's going on in these other rivers, we're always happy to chat about that stuff too. We also monitor beyond phosphorus, lots of nitrogen, and we're going to get into a little bit more in the upper Scioto in the coming months too. So yeah, so I'll leave it at that. I don't know if that's exactly where you're going with, Steve, but we'll leave it at that for now.
That is awesome. It's awesome context, and it's great information. So I want to thank all of our panelists, Laura, Les, Adam, and Greg, for your help both with the video and with today's panel. And I honestly wish we could talk another hour, because I think there's a lot of great information to be shared. I also, since we do need to wrap it up, I also want to thank our sponsors who've made this possible. It's as Chris mentioned earlier, this is so vital to making this information available and available free. The information, as I mentioned, will be both on the American Society of Agronomy's website eventually, and also on our site, ctic.org, along with some bonus content. Tag us on Twitter, CTIC_tweet. And again, thank you so much to the American Society of Agronomy for letting us be part of the program.